minasyaitanirrajim. Bismillahirrahmanirrahim. Alhamdulillah, masyaallah, tabarakallah, alhamdulillah, Allahumma salli ala Muhammad wa ala ali Muhammad. Inshallah, in this video, we go through the derivative of arc sine of x. Consider y is equal to arc sine of x. Then we sine both sides of the equation, giving us sine y equal to sine arc sine x. Hence, we will have sine y equal to x. Then, we differentiate both sides of equation with respect to x. So, we differentiate sine y with respect to x on the left hand side. We also differentiate x with respect to x. Then on the right hand side, we will have cos y. Then we differentiate y with respect to x, giving us dy dx. And then on the right hand side, the value is equal to 1. So thus, dy dx is equal to 1 to cos y. So in order to find the differentiation of the arc sine x, there are two methods. Method number 1, we use a drawing method, where this is a right angle triangle, where the angle is y. Given that sine y is equal to x, which is equal to x to 1, where we know that sine is opposite, where the opposite side to the angle is x, and sine is opposite to hypotenuse. Therefore, the hypotenuse is this side, and which is the value is equal to 1. Therefore, we can find the adjacent side to the angle y, where by applying the Pythagoras theorem, so the adjacent side is equal to square root of 1 square, which is equal to 1, take away x squared. So, given that we found out that from our previous solution, dy dx is equal to 1 to cos y, where we know that cos y is adjacent to hypotenuse, where adjacent side to the angle y is equal to square root of 1 minus x squared, and its hypotenuse is 1. Therefore, cos y is equal to square root of 1 minus x squared. So we sub this value into dy dx. Therefore, it given us dy dx is equal to square root of 1 minus x squared. Since we know that y is equal to arc sine x, when we differentiate both sides with respect to x, it giving us the value of dy dx on the left hand side, and it remain in the form of d dx arc sine x on the right hand side, which is this relation is equal to 1 to sec 1 minus x squared. And this formula is given in the question paper. Okay, method number 2, we can use a basic identities, where we know that by basic identities, sine square y plus cos square y is equal to 1. Then we eliminate both sides. We take away both sides with sine square y, giving us cos square y on the left hand side, and then 1 take away sine square y on the right hand side. Then we square root both sides of the equation, giving us cos y on the left hand side, and square root of 1 minus sine square y on the right hand side. From our previous relations, we know that sine y is equal to x. Therefore, when we square both this equation, it's giving us sine square y is equal to x square. So therefore, given dy dx is equal to 1 to cos y, thus we sub this value, so dy dx is equal to 1 to square root of 1 minus x square. Since y is equal to arc sine x, so we differentiate both sides with respect to x, it giving us dy dx is equal to d dx arc sine x, which is equal to 1 to third 1 minus x square. Masya Allah, tabarakallah, alhamdulillah, Allahumma salli ala Muhammad wa ala ali Muhammad.